Big data analytics helps organizations to harness their data and use it to find out new opportunities for their organizations. So, understanding this, we have brought you this video on big data analytics for beginners. In this video, we'll have a proper introduction to the field of big data analytics, understand its landscape, and we'll also have a quick introduction to Hadoop.
Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.
So welcome to everybody. Our session today is a bit about understanding the big data landscape. Now, you've all heard a lot about various aspects of big data and hundreds of different tools and technologies and so on. Today, we're going to demystify that a little bit. Before we start, just to introduce myself, my name is Harish. I am the program director for our postgraduate program in big data analytics. And with me today is Vinod Venkatraman, who holds a BTech degree from IIT Bombay in computer science and has then gone on to do remarkable things in the technology industry, among which he spent 7 years at Stratify, a Silicon Valley-based product firm, and then he spent a big chunk of his career at Flipkart, where he was a software architect. And what Vinod is going to talk to us about is a bit about the big data landscape, what all the moving parts are, what the relevant parts are, and which parts of it make the most sense for you as you look to perhaps learn some of these technologies and use them in your jobs. I'm handing it over to Vinod.
Hello everyone, this is Vinod. Thanks Harish for the great intro. So I hope today we'll be able to demystify the big data landscape a bit for you. So as you can see on the slide being presented, that if you just open up any diagram consisting of the big data technology stack, you're going to see so many moving elements. Names which you might have heard, names which might sound like cartoon characters and things like that. A lot of animals as well. But the whole idea is that you need to understand what each tool is meant for, instead of really understanding, how each tool works. And today we'll try to cover that part where you understand the tools presented here and what role they play in the big data stack. Before we dwell deeper into the big data landscape, I'd like to cover what is the big data value chain. So basically, as data gets accumulated in an organization, there is a value chain through which you can actually take it and derive insights. What we have here are the steps to do that. The first step obviously is to find the data that you want to analyze, which is the source data aspect. Now the data itself might reside in different systems, might reside in different technology stacks, and so on. The key is to identify what data you need to do the analysis you want to do, and identify systems from where you need to get that data. Once you do that, the next step is to actually ingest the data into the big data landscape. That is, get the data into an environment where it can be analyzed. That is the ingest data part. Once you have the data ingested into the landscape of big data, then the next step is to prepare it for analysis. So what do we mean by that? Preparing for analysis could be, simple things like estimating the amount of data you've gotten. Could be complex things like removing the outliers which will skew your analysis. Or could be intermediary simpler things like normalizing data. Maybe there are 4 or 5 variants in which the same thing is referred to in the data, and you want to normalize all of that so that you can refer to that part of the data with the normalized name. So that is the prepare data part. So now that we have the data ingested in, we have it cleaned up, we have it prepared, the next is to store it in the right way so that we can do our analysis in the big data world. Now, what do we mean by storing data? In the big data world, storing data could mean as simple thing as, putting it in the right, folder structure, putting it in the right format. And then the last step, which is to analyze this data using the big data techniques. To analyze this data, you will be using most of the technology elements that you saw in the previous slide. A few of them will also help you to store this data. A few of them will also help you to prepare this data. So essentially all the tools that you saw in the previous slide play some function in these steps in the value chain. So we start our exploration of the big data landscape at the core. And the core of all big data analytics is Hadoop. You must have all heard this name, hence your interest in this webinar. But let's try to understand what is Hadoop at the core. At the core, Hadoop has three components. One is the distributed file system, which is called HDFS. It stands for the Hadoop Distributed File System. This component essentially plays the store data path part in the value chain. This is where all the awesome big data you have collected is stored so that you can then use techniques like MapReduce to derive some insights. So MapReduce is one algorithm, one distributed algorithm with which you can process the data that you have just stored in your HDFS layer. So MapReduce is an algorithm which runs, has two steps, the map and the reduce step, both of which help you put data of similar kind together and then draw in the reduce step, you draw an insight from it. So we have HDFS, which is where the big data is stored. We have the MapReduce algorithm, which helps you analyze the data. But who conducts this? When you submit a MapReduce job or when you do MapReduce, who's responsible to actually get the job done? And that is what is called Yarn. Yarn essentially is like the brains of the Hadoop core. It is the one which knows, how to execute the MapReduce job, where to send the job, which machines to choose. If a machine fails while executing the task it's assigned, how to handle that. Essentially, Yarn is like an orchestrator of the MapReduce workflow. Now that we have a basic understanding of Hadoop core, which is the heart of the landscape, let's move outwards and see what all is built on top of Hadoop. So the way we are going to analyze this landscape is actually take use cases that we have all heard of and then see what technology components exist in the landscape to solve them. The first use case obviously is something we have all heard of, is called data warehousing. Data warehousing is essentially a process in which enterprises collect all the data that they have in different systems into a warehouse and then do ad hoc SQL queries on top. This in the Hadoop ecosystem or in the Hadoop landscape is provided by Apache Hive. So Hive essentially is the data warehousing solution that Hadoop provides. The next thing is when we have had data in our databases, traditional databases like Oracle or Microsoft SQL Server, we run SQL queries on them. That's all fine. But sometimes we also run scripts on the data in the form of stored procedures and so on. So the equivalent of that in the MapReduce or in the Hadoop ecosystem is called Apache Pig, which essentially provides you the ability to run scripts that you write on top of the data present in Hadoop. So when I say you write scripts, what language do you write it in? You write it in something called Pig Latin. So essentially Pig Latin is the language in which you write your scripts. And it's a new language introduced by Pig, which helps you write PLSQL or stored procedure like scripts, which can run on the data stored in Hadoop. Moving on, another common use case that we have all seen is called the ETL. ETL stands for extract, transform, and load. What essentially is, it is a process in which you can get data from one source, transform it, and load it into another source. So in the Hadoop ecosystem, the software component called Apache Scoop provides you this standard technique. Essentially, what it allows you to do is to take data, that exists in different, traditional systems like relational databases, and run an ETL job on top and load it into Hadoop. So if you have a lot of data existing, in your enterprise in databases like Oracle, you can use this scoop tool to essentially extract it, transform it, and prepare it and load it into Hadoop. By the way, Scoop also provides you to do the reverse, where once you have analyzed and drawn some conclusions, some insights, you can extract the data from Hadoop, transform it, and load it back into your original systems, your systems that your enterprise is more comfortable working with. The next aspect is machine learning. This is something we experience every day. Be it when we go to an e-commerce website, or you go to any shopping website, you go to any travel website, you see, things that the system is suggesting. So if you went to place X, it will suggest where else you can go. What are the things you can do there, which are fun. Similarly, when you go to an e-commerce website like Flipkart, it will suggest if you buy something, what else you can buy. So these are all things which are derived by the machine learning angle. So the machine is learning from what other people did, and based on that, it is suggesting what you should do based on your behavior. So the machine learning aspect in the Hadoop ecosystem is provided by Apache Mahout. As you all know, Mahout is basically a person who tames an elephant, and Hadoop itself, the icon or the logo for Hadoop is an elephant. So Apache Mahout essentially gives you the ability to use standard machine learning algorithms on the data that you have gathered in the Hadoop ecosystem. Moving on, what if I do not want to store raw data in Hadoop? What if I want to store data which I want to access given an identifier? Basically, what if I want to have an Oracle-like thing on Hadoop? So such databases which can scale to a lot of data. And when I say a lot of data, it's not just in terms of the number of rows, but also in the number of columns, which essentially means that your data has a lot of properties, has a lot of aspects to it, all of which you want to store and then retrieve. So such databases are classified as big databases. So they are big not only in the number of rows, but they are big also in the number of columns that each row has. By the way, most of these big databases also provide you the ability to have different set of columns for each row in the same table. So these big data databases in the Hadoop ecosystem, a couple of implementations of those are Apache HBase and Cassandra. So HBase comes, with the standard Hadoop stack. Cassandra is something you can install on top. Now that we have seen 5 common use cases around data, and we have seen what is the equivalent technology that the Hadoop stack provides us, we have sort of entered into the deep territory of the landscape. So we started with trying to explain the big data landscape, and we just jumped into Hadoop. So is big data there beyond Hadoop? Yes, of course there is big data beyond Hadoop, and there are big data tools that exist beyond Hadoop, which are classified into these 3 broad categories. First is a set of NoSQL databases, and when I say NoSQL, it does not mean they do not support SQL. What NoSQL actually stands for is not only SQL, which means you can do way more than what you can do with SQL-like interface. An example of a couple of such databases, of NoSQL databases, are Cassandra and MongoDB. So these are again databases that you would have heard of, but both of which provide you the NoSQL aspect. The other kind of big data, technology stacks that exist beyond Hadoop are distributed search engines. Now, a search engine is something which can, search through data and give you back results, and rate them and rank them. So give you back the most relevant results from a collection of data. Now, as data has been growing, so has the need to search through data. Not every time you want to do, a Hadoop MapReduce job on top of data. Sometimes you actually want to find the most relevant data for your users and present it to them. For example, in the Flipkart use case, if someone is, searching for, something like 5-star rated TVs. Essentially, that is a search query, which can have further filters like, from brands like X, Y, and Z, and things like that. So now you have a lot of data, which is essentially all the products in the Flipkart ecosystem, but you also need to search through and present the most relevant products based on the search that the user is entering. So for these use cases, distributed search engines have been built. And examples of a couple of those are Solar, which which was the first distributed search engine that was open sourced, and of recently, a search engine called Elasticsearch has got a lot of attention. So at Flipkart, we extensively used both of these technologies, Solar and Elasticsearch. So whenever you search on Flipkart, essentially the query is directed towards a Solar distributed engine, which retrieves the products matching and shows it to you. Now, moving to more use cases that are beyond Hadoop is real-time stream processing. Most of the time, what happens is, you have data that has already been collected. Maybe, you have data of all the orders placed in your company or in your business in the last 5 years, and you want to analyze them. So for such use cases, you can just load the data into Hadoop, write your Mapreduce jobs, derive insights. But sometimes we don't want to wait. We want to derive insights on the fly. For these use cases, especially, we need real-time processing. What we mean by real-time is as soon as the actual data is produced, it is included into the analysis, and an incremental insight is derived from it. So for real-time stream processing, an example could be, if you take the Flipkart's Twitter handle, we all know that it gets a lot of tweets. Some tweets are happy customers, expressing their gratitude, and some tweets can be angry customers, letting us know that we couldn't meet their expectations. So a real-time stream processing in this case would be a system which is reading through all the tweets made at the Flipkart handle and continuously classifying that tweet as a positive sentiment or a negative sentiment, and also identifying tweets which need to be acted on immediately. Because we don't want an angry customer to raise a complaint and then wait for a day, 2, 3, 4, 5. So a system like real-time stream processing is nowadays, especially with social media, a real use case that needs to be solved, and it is actually a big data problem. Because just reading the text of a tweet, you need to figure out what kind of sentiment it has, and all of that. So, and a stack in the Hadoop, beyond the Hadoop, which helps you do this, is Storm plus Kafka. So Storm essentially is the processing engine here, and Kafka is the queue where every tweet enters, waits to get processed by Storm, and the output is essentially the real-time insight that we are looking for. So big data beyond Hadoop is essentially one of these three categories: NoSQL databases, distributed search engines, and real-time processing. We spoke about Hadoop in the landscape of big data. We spoke about, three other types of use cases of NoSQL, of stream processing, and, and now I would like to take a special mention for a technology stack called Apache Spark. So this distributed system came into being most recent among all of these and has taken the entire big data world by storm. It has essentially sparked the big data engine. So Spark at its core is a fast engine for processing large-scale data. That essentially is the one-line definition of Spark. But what it provides you essentially is a set of capabilities. So if you remember, we spoke about how Pig allows you to write scripts on top of data in Hadoop. Similarly, Spark allows you to do scripting in more popular languages like Python and Java. Spark itself is written in Scala, and it also provides you to write scripts on Scala which you can run on data, right? But where is this data stored? So the beauty of Spark is it can access data stored in a database, it can access data stored in Hadoop, it can access data stored on the cloud. It can basically has connectors for data residing in most places. So what Spark does is something like what Pig does to the Hadoop ecosystem. So Spark allows you to write scripts which can run on data stored in nearly all imaginable data sources. We remember that Hive allows you to, run SQL queries on data stored in Hadoop. So Spark also gives you a SQL component with which you can run SQL queries on data stored in nearly any system. And that Mahout allows you to, do machine learning on data in the Hadoop ecosystem. Now Spark also has something called MLlib, which stands for Machine Learning Lib, which allows you to run standard machine learning algorithms on data. And when I say data, it's again data stored in many different types of data sources. So Spark, it's like a Swiss Army knife, right? So it doesn't end here. It also provides you with stream processing, with which you could do use cases like the Twitter handle use case we discussed, right? And it also has a graph processing engine, which essentially allows you to process and run, extract insights from graph data. So when I say graph data, this particular stream of data has got a lot of importance in the last 10 years. In the last 10 years, with advent of Facebook, Twitter, and all these social media platforms where we are creating graphs of friends, graphs of information, we need tools now to handle all this information at scale, and this data is growing by the second. So Spark has something called GraphX, which essentially allows you to derive insights from graph-like data. And as I already mentioned, it can access data stored in most data sources. The other beauty of Spark is it can actually run anywhere. You can run Spark starting from your laptop to all the way to the Amazon EC2 cloud. You can run Spark on one node, you can run Spark on 1,000 nodes. That's also very similar to Hadoop. So essentially a special mention to Apache Spark, which provides you with most of the tools that you need, to navigate through the big data landscape. So far we have seen, what are the various components that exist in the landscape, what are the different types of, tools that exist, what are the different types of things you can do. But finally, all the tools helped you to do one thing, which is to, understand data, draw some conclusions, find some insights. So all of these insights, once found, have also need to be documented, need to be saved, need to be, visualized so that others who look at this data can also understand. So for that, what essentially is done mostly is to create reports and dashboards. Reports are more like things, that, maybe give you a pie chart, maybe give you a bar chart, a scatter plot, and so on and so forth. A dashboard is basically a set of reports put together, which cover a particular aspect of the business. So in the Flipkart use case or any e-commerce use case, one such dashboard could be the orders dashboard, where we see, the top selling products, we see the top buying users, we see the, the amount of the revenue that has been generated in the day, in the month, and so on and so forth. So reports and dashboards have been the traditional way in which we present data and insights from them. But truly what has started to pick up is basically telling data-driven stories. So reports and dashboards throw numbers at you. They give you data, but they don't tell you a story. The story has to be inferred from them. But nowadays, what data scientists around the world are trying to do is to take something that has happened and use data to explain why it happened, or predict something that will happen and use data to say why it would happen. So essentially, there needs to be ways and tools with which you can have present your data-driven stories. Now, coming to a different form of visualizing data is real-time dashboards. So a real-time dashboard, if any of you have worked in technical systems, most of the technical systems have a dashboard where you see how many requests are failing, how many are passing in the last few seconds. The reason this is important is if, let us say, you build a website, put it out, and you go home, you sleep happily. But there has to be some way for you to know whether my system is working right now. And right now, this essentially is the real-time angle. So you need to have real-time dashboards to be able to answer questions like, is this thing happening right now? How much of it is happening? and have thresholds defined beyond which you should raise alerts. For example, if your homepage, your landing page is throwing errors, and if it is throwing more than 2 errors in the last 1 minute, then somebody in your team needs to be looking at it. So real-time dashboards is also another very important way in which people are understanding data that is happening at this point in time. So in the big data landscape, you'll also have tools which will be used to analyze and create all these types of visualizations, be it reports, be it dashboards, whether real-time or historic, and have the ability to for you to create a story driven by data. So Tableau is one such tool which allows you to do these things, and so is Jeffy. So in the last half an hour or so, we have kind of taken a 10,000 feet view of the landscape, seen all the things that exist there. But the key takeaway is this landscape is ever growing. Tools are getting created every day by different companies, be it Twitter, Facebook, be it there's so many companies who are working on improving the big data landscape, because that is actually the burning problem of the day. Being able to use all the massive data you're collecting to predict business insights, to find business insights and predict behavior. So the key takeaway that I want you all to have from this is to not get overwhelmed. Yes, I understand, the landscape is growing, it's wide, but if you know the key concepts and if you know which tool does what, and you should be able to apply that tool. So it's not about knowing the entire landscape, but it's about knowing the regions, knowing what each region is capable of solving and what tools exist there. And on a need-to-know basis, you can dive in deep, get your hands dirty with the tool, and actually answer and get the insight that you are seeking.
Who can tell me what is big data? So that is the first question. Who can tell me what do you mean by big data? Have you heard this term anywhere before? The definition of big data, if you Google, you will get. First thing, you can just go to Google and say, what is big data? You will get tons of articles, PDFs and presentations. That is not what I'm going to teach you. Let's take a practical use case, right? Let's take a practical use case and try to understand how big data actually makes sense, right? First of all, big data is related to IT. So you need some level of IT knowledge to be fair, right? This has something to do with IT. I will share my personal experience, okay? So when I started working in 2007, 2008 and all, okay, I was working with a company in Bangalore, and we had created an application, a sales application. So basically what we'll do, if you install this application, there was a retail company, the customers will input all their sales data in that, so they will say that today this much quantity item sold, sold and sold and sold. And this application will capture all the data, okay, and store it. Now that was a very simple world. We did not have mobile phones, we did not have Facebook, WhatsApp, nothing was there, 2005, right? And we were using an Rdbms system to store this. You know what is an Rdbms? So Rdbms is what we were using to traditionally store the data, right? And what is an Rdbms system? It has a row column format. You have a table. You insert the data. Now, if somebody is teaching you Rdbms, they will say that, well, Rdbms is great. It can store everything, that's all fine. But unless your data starts increasing, right? So originally, Rdbms can store everything. I don't have any, I'm not against Rdbms or something. Even for transactional management, we use Rdbms. There is no doubt about it. MySQL, Oracle, we were using MySQL actually. So whatever the customer is inserting, this MySQL will capture it. End of the year, you do some processing. You will understand how many items were sold. Everybody is happy. This is what was happening in 2005. Fast forward to 2011. I am working with ICICI Bank. ICICI Bank want to migrate to big data platform. So what is the problem with ICICI Bank, right? So that is the question. Why ICICI Bank want to go to big data, right? Now, this example will also help you to understand the IT world, right? So for people who are not coming from the IT background, they might need to understand how things are working, right? So we went to ICICI Bank, we spoke with them, we said, hey, what do you want? They said, you know what, we are facing a lot of problems. We want to go to big data. We want to go to Hadoop. We'll see what is Hadoop later. So we asked, what is a big deal? What is your problem? So there were a lot of problems which they were facing. One of the problem is that if you look at this Rdbms system, right? Your typical Rdbms system. What is Rdbms systems doing? They will store the data in the form of a table, right? Now, if your table size is very, very small, it's not a big deal. Even if you look at MySQL or if you go to enterprise scale Oracle and all, they can store gigabytes and sometimes up to terabytes of data. But as the size becomes big, so let's say I ask you, okay, you have to store the data in Oracle. The data is keep on increasing every week. You are not ready to migrate anywhere. Oracle, if you talk only about Oracle, they have storage separate and DBMS engine separate. In Oracle, what I can do, I can purchase Oracle and I can add storage boxes, as many as I want. So these boxes will be in the network. So my database engine will be connecting to them and storing the data, whatever data I'm giving. So you can argue saying that I can increase the storage capacity and then Oracle can store as much data as you want. There is no doubt about it, right? But there is also a limitation for this storage, one problem. Second problem is that as this box increases, the storage in Oracle increases, you have to divide your data. So you are selling iPhone, let's say you're working with Apple, right? So one of the example is that if you are creating tables to store iPhone data, typically if you look at the schema and all, what we will do is that there will be one table, okay? There will be one table wherein you will be having properties like, how many items were purchased, at what rate they were purchased, how many people bought, so on and so forth. So this will be your items table. So in the items table, you will have all the data related to the iPhones you were selling, right? You will also have another table where there will be the user data. You will also have the user data. You know what is normalization? In Rdbms systems, in order to avoid duplication of data, what we do is that we normalize the data. We always keep the data in different tables. So if I want to get both the data from this, I have to do something called a join query. I fire a join query and all the data from here will come and join and produce me the output. This is good if you're having small amount of data. What if you have terabytes of data here and here? My join query will fail, right? Or the join query has to wait. Now, another point that people say is that if your Rdbms is becoming bigger and bigger, why don't you partition your data? That is possible. I can have like 4 boxes, my one table, okay, if this is my table, right? It can be logically partitioned and kept on 4 machines if it is becoming bigger and bigger. Okay, this is possible. There is something called logical partitioning. Look at the iPhone data. I can say all the data where people from India are buying the iPhone, go to this machine. That's called logical partitioning based on the country column. So here I have all the India data where people are buying iPhone. Here I have the US data where people are buying the iPhone. But the problem is here I'll have the Burma data also. India data will be, let's say, 2 terabyte. China data will be 3 terabyte. This will be KBs actually. Because in Burma, I don't think a lot of people are actually buying iPhone, probably, right? Exactly. So the problem is that if a table is becoming so big, okay, I can cluster it. I can take 4 machines in my Rdbms or data warehousing architecture, and I can say partition the data. Because if a table is so big, if I fire a query, the query will take a lot of time. So what I do, I say that, okay, don't store the full table, divide the table or partition the table. To partition, I will say that you have to use some logic for partitioning. I cannot physically divide the data. That's not possible in Rdbms. I cannot say that take a table and cut it into 4. Doesn't work. So I have to logically partition. So I have to say that there is a country column. How many countries are there in the world? Maximum 155, right? I'm not much of a geography person, but I think somewhere around 155, right? Or at least people who buy iPhone, 155 countries are there. So I will say take the country column. So everybody who is buying an iPhone will have a country column. So based on the country column, it will partition your data, right? Now I have 4 boxes. This box has India data, US data, Burma data, and something data. Again, same story. If you're running the join query, this box has to process all the India data for join query. This box will complete very fast. This guy has to wait. So again, so the problem is that traditionally people were using Rdbms systems and data warehouses to store the data. Now, what is the drawback? One of the drawback is that As the size of the data increases, your processing will become very, very slow. Why don't you denormalize the data? Why don't you denormalize the data? For example, all the transaction data, user data, everything I'll keep in one table. Is that possible? I can't do. So that is the reason they don't provide the denormalized solutions. If you look at Rdbms systems, they will always say normalize your data, so that it will be represented in different tables, and whenever you need the answer, you do a join and you get the result. Second drawback, this is only structured data, meaning anything which you can represent in row column, I can dump here, like an Excel sheet data, right? Can I dump images and audio files in this table? Yes or no? Can we store unstructured data in Rdbms? Yes, you can. There is CLOB, blob, and all objects, right? But can it process unstructured data? Not possible. So, size of the data increases. It cannot cope up with processing. One of the problem, right? Second problem is the schema. Meaning, anything which you can represent in a row column format, I can dump in an Rdbms. Anything apart from that, I have to figure out a solution. So what is the actual solution if I have to store images and retrieve them in real time? How does Flipkart stores the data? I was working with Flipkart for some time. Flipkart has around 10 million products. Each product has 10 images. That is 1 billion images. So when you click on a iPhone X picture on Flipkart, Flipkart will say that come after 10 minutes or immediately display. Have you ever thought how it is happening? How it is happening, right? So do you think they're dumping in an Rdbms and picking it from there? 1 billion images. There is a whole arena of databases called NoSQL. If you have heard about MongoDB, Cassandra, HBase, Neo4j, Voldemort, these are all popular vendors of NoSQL database. So NoSQL databases will help you to store and retrieve unstructured data at any speed you want. So what Amazon.com actually does, Amazon has something called DynamoDB. DynamoDB is a NoSQL database. So in DynamoDB, I don't have a row column. I have key value pairs. So what they do, the key will be the product name. Say you are clicking on iPhone X. iPhone X is the key. The value will be all the data you have. So the moment you click, boom, your page is there. So NoSQL databases are really faster. Also, it helps you to store unstructured data. How are you booking a cab using Ola? If I try to get a cab using Ola, right, I open up Ola. How many customers Ola has? Millions in India. And all of them are booking at the same time, right? Do you think all your requests are taken by an Rdbms and searched in the table and give you a cab? Does it work? Can an Rdbms system handle 30 million, 40 million concurrent sessions on this amount of data, calculating route? MongoDB, NoSQL database. Ola runs on MongoDB. I was working with Ola for one of their design problems actually. So I didn't design anything, but they told me that they are using MongoDB. So the second drawback of your Rdbms is scalability is there. Okay. Third is price. Price is a problem, right? I mean, obviously, if you calculate the cost, if you look at Oracle and all, they are very, very costly solutions. Traditionally, storing the data on an Rdbms and retrieving is not good for the modern day. In the modern day, what is happening is that every company wants to collect and analyze the data. Be it banking industry, e-commerce industry, or any industry that you want, they want to collect and analyze the data. So to give you an example, if you visit Amazon.com or Flipkart.com, what is happening? They start tracking from which IP address you are visiting the website, how long you are clicking on a page, which items you are adding to cart, which images you are clicking, which offers you are clicking. All this data is analyzed to understand how a customer will behave. That is how they do marketing, right? So the more you start visiting the e-commerce companies, you start seeing recommendations and all the more. The more you visit Amazon, they will start recommending products to you, asking you to buy. So they have to collect all this data. So when I was working with Flipkart, Flipkart said that they collect data from the apps that you're using, from the website that you're having, even from social media. Flipkart is very active in social media, like Facebook, Twitter, all these places they are active. So if anybody tweets about Flipkart or visit their Facebook page, all this data is being collected. Now this is actually called a big data. So the technical definition of big data is this huge amount of data which you cannot process using your traditional methods. That is called big data, right? So why that is of interest to us? We are going to figure out how to store this data, huge amount of data, right? And how to process this data. When I say NoSQL databases are there, it does not mean your Rdbms is gone. So many people ask this question. Okay, Rdbms is the only solution for transaction management. So even if you're buying something from Flipkart, who will complete your transaction? Oracle probably, or any transactional system. For transactional management, and why is that? Because Rdbms systems are the only ones which can ensure the ACID properties, right? If a transaction goes or not goes. You bought something from Flipkart, tomorrow Flipkart cannot come back to you and say that, I don't know whether the transaction happened or not. Probably you got the money. It's not possible, right? Then you will start complaining again Flipkart, right? So Flipkart comes to you and say that, you know what, we are using Cassandra. As per Cassandra, your transaction is, we don't know, we'll come back to you in another 1 week. Is that possible? No. So transaction management, very good question, is still handled by RDBM. Polyglot persistence. In the world of big data, there is a separate category of systems called NoSQL databases. And they are databases. So what is a database does? Real-time, queries, right? And in that area, we have MongoDB, Cassandra, HBase, and these guys. Now, these guys are used in real time if you want to fetch the data. Say, for example, you are opening an e-commerce website. Probably it is given by a NoSQL database, right? Or millions of people are booking flights through cleartrip.com, and Cleartrip has to identify, how many people are booking in a particular route so that it can give a better offer. This is probably done by reading real-time data from a NoSQL system. Our area is not NoSQL. NoSQL is a DB actually, it's a database. Our area is not NoSQL. We will come to Hadoop, right? Now, so this is the technical term for coexistence of DBs and NoSQL and all. So ETL stands for extract, transform, and load. So what is the idea here is that, see, if I'm working with a company, right? The company will have RDBMS systems, right? So these are all RDBMS systems. So probably this guy is using MySQL, and he's also using Oracle, right? A lot of RDBMS systems are being used by a company, right? Now these are all serving the customers. So if you take the example of ICICI Bank, all their core banking data is in Oracle. All their core banking data is in Oracle. So if you are making an online transaction, the data hits Oracle. All their CRM data is in MySQL. What do you mean by CRM? Customer relationship, right? Your name, address, blah, blah, blah. So they have these two types of data. Now, is this the only type of data that they have? No. ICICI Bank had also acquired a lot of other companies when we were working with them. So their subsidiary companies were giving them data in the form of XML files. XML, right? Now, ICICI Bank also had a Facebook page, okay, from where they were getting around 10,000 people visiting every day that Facebook page, and they used to click on some item. So they have to do this cross-selling, upselling. If a user goes to Facebook page and say that I really like your loan, take more loan, right? So that is your cross-selling and upselling, right? So what they do, they collect all this data from social media. That comes in the format of what? JSON. JavaScript object notation, JSON, key value pairs basically. So this is where their core banking data, this is where their CRM data, this is from their partner companies, this is from the social media data they are getting, okay? This one, the social media data, they want to do analytics. So every day 10,000 people are visiting their web page. They want to know a person clicked on, let's say, a loan offer and how much time he stayed on the page and what age group he belongs to, so that they can recommend products, recommendations actually. A lot of recommendations. So social media data was being used. They did not reveal all the things that they are doing because that were internal to, but basically using the social media data, they were doing recommendations. So they will download all this data. So if a customer is clicking on the Facebook page, they will get the access of this guy. If you are clicking on ICICI Bank's Facebook page, They will know your age, your occupation, everything you shared in Facebook. That is by default given to them. In most of the cases, you can restrict the information, but most of the public customers, they will share this. So by downloading this data, today they will understand 10,000 people clicked, and out of them 5,000 were youngsters, and they clicked on this loan. That means the trend is towards a particular bike loan. If we give an offer on bike loan, youngsters may actually buy it. So this is analytics, right? So all the social media data they can use in multiple ways actually. So this was getting in the JSON format actually. And this type of data was there. They also were collecting their customer care log files. So that is again flat file. It was coming in a format of flat file. Flat file means text file. So customer care log actually means the chat logs that they were having, also the call logs. They don't get the actual call, but how long the call happened and what you pressed. So when you call customer care, you press, right? This. That is actually captured. And then they want to figure out how many people are called on what category, how much time they spent, right? So if you are clicked on a complaint button and you talk for 1 hour, chances are very high you are a bad customer, right? I mean, 1 hour you're scolding probably, right? So they want to figure it out, right? So that is the call record that was coming in flat file, this format, right? And at that point in time, ICICI Bank also wanted to offer a solution. So previously what they used to do, their agents were there, people who go to your house and make you buy loan and all. So they used to go to every place. So this agent will get a list and he will go to that place and he will go to your house and say that, sir, please take a car loan. You will say no, he will say buy. He will get money. He is getting salary, right? So this technique was not working because if I get a list, okay, one customer will be in, one guy will be in OMR, another guy will be in some other remote place in Chennai. So by the time he travels from here to that place, day will be over. So he is able to cover only 2 customers. So what ICICI Bank had in mind, they will track his location. He has a device, okay, and give him customers in real time. So if he's in Kannanjavadi, he'll get all the customers nearby him. So this guy has to go, right? He cannot say I can't go. So he will, the customer application, it was a tablet, will track this guy. And wherever this guy goes, the nearby customers will be provided to him. So he can cover more customers, right? And this has a lot of impact because why it was practical? Because sometimes the customers will call and say that, please come, I'll give you a loan. So what you do from here, you might travel to Paris, right? And because the customer called, right? So you go to Paris and meet the customer. Now you don't know how many customers are around Paris. That this application will track and send it to you. So these guys were collecting that data also from all the tabs. And that was quite some big amount of data they were collecting. So how many customers they met and whether they closed it or not closed. Okay, that was coming in, I think, some other format. So some format I forgot actually how it was coming. So this is the whole data they have, right? And some more data was there. And this data is lying on different systems. It's not in one place. The core banking data is in Oracle. Some other data is in some other place, right? And if you want to analyze this data, one thing is that I cannot go to Oracle and say that I want to analyze your data. Why? Because this Oracle DB is already busy serving customers. Correct. This Oracle DB is the core banking database. So if you are making a transaction, Oracle is handling that, right? So I cannot go to Oracle and say that let me run some analytics on your data. Doesn't work that way because then Oracle will slow down. I can't do that. So I have to take all this data from all these places and dump it into a central place. So that is what is you call as your data warehouse, right? That is called a, how many of you know what is a data warehouse? So a data warehouse is nothing but a database only in one way. It understands the language of SQL, but the major difference is that it is not facing the customer. So you will do something called ETL, okay? So there are ETL tools which can get the data from all these places, right? And this guy will dump it into a data warehouse, right? So data warehouse is also called as your OLAP, online analytical platform, so on and so forth. And what is the purpose of this guy? So this guy will have all the data from here. Okay, and you can transform the data as well. So that is why it is called ETL, extract, transform, and load. You don't just take the data and dump it here, then it is useless, right? I can read the data from a flat file and give some structure and then dump it here, like a proper table format. So now all my data is here from this, right? And I can run business intelligence here, BI tools, Tableau, right? If you have heard about MicroStrategy, Tableau, what I can do, I can connect a visualization tool here and it will show me in charts and diagrams what is happening. I mean, this is traditional enterprise architecture. This is how people used to work forever. I mean, every company you go, this will be there by default. They will have these disparate, discrete data sources and ETL tools. So if you have heard about Informatica, Informatica is one of the biggest ETL tool. Informatica, Talent, Pentaho BI, SSIS. So these are all ETL tools. So these tools, what they do, they will connect with here and take all the data and apply some schema and push it to a data warehouse. Now the data will be here. So now all the data is in one place. So Chandra Kochar may not know SQL, right? You can't expect that, right? If you're a CEO of the company, I can't ask you, do you know Java? I'll be fired next moment, right? So, but the CEO want to know what's happening, right? By getting all this data only, you will understand what's happening in the company. But you don't have time to sit and learn all this language or anything. So if I'm Chandra Kochar, I'll go here, I'll connect my Tableau, and I'll ask my Tableau, show me the last month's transaction, this quarter, this product, this area, show me, it'll show a nice bar chart. Now, why this is very, very important? If you make any mistake in any of this entire stuff will be changed, right? And what she sees will be different, right? She has no idea how this is happening, right? Only you know how this is happening. So your ETL tool should run proper, the data should be captured and dumped here and then analyzed. So for CEOs and CTOs, they use visualization tools to connect with a data warehouse, then analyze the data. So all the data is inside this data warehouse, right? And this is not accessible by public. Public has no access to this. Only internal company has access, like maybe CEOs of ICICI Bank, they can go here and visualize the data from here. Others, public does not have any access to here, right? And then they visualize the data, they make a decision, they may not make a decision, that is up to them. In the whole setup, there is no Hadoop so far. And this is how ICICI Bank was running so far. Now, what were the challenges they faced? One of the challenge was that this ETL tool, okay, I don't know how many of you have run on ETL tools, okay? They typically run on a single machine. So there is a limit as to how much this guy can pull to a data warehouse. How much amount of data this guy can pull from here to a data warehouse, there is a limitation. You can't have terabytes of data being pulled. Point number one. Point number two, none of this is real time. I go to Tanishq store, Tanishq is a jewelry stuff. I go to a Tanishq store, I buy something from there for 20,000 rupees. I use ICICI credit card. I should immediately get a message saying that again you shop 20% discount. That is real time because all this is separate data and these ETL jobs run at the night. So today morning if I'm shopping, tomorrow I'll get the message 20% off. By the time I'm out of Tanishq shop, right, I may not use it at all. So ICICI Bank's first problem was that since the data was increasing, they were not able to run ETL properly. Second problem, none of this is real time. They wanted to push customized offers. Their requirement was that whenever any transaction is made, they want to capture it, analyze it, right? And based on that, they have to recommend something to the user using credit card or debit card, or even you're clicking on some link, immediately something should happen. Now that is not so easy, right? Because your data might be somewhere in here, Oracle, and I cannot track each and every transaction here because this is my transactional DB. I can't say that track each and everything from here, right? That's not possible. Third problem, this data warehouse. This data warehouse is a very costly affair. I have worked with a company called Teradata. They are the leader in data warehousing market. I had a US client, they were using a product called Teradata for data warehouse. They were paying around $5 million every year only for this setup. Now it is good. You can analyze the data and all, that's okay. But you're paying a lot of money actually. So data warehousing is actually a very costly affair. It's not so cheap if you want to implement. But companies like ICICI Bank, they must use it, right? So they can't say that we will not use it. So they wanted a cheaper solution. They don't want all their data in this data warehouse. They want an alternate solution. It should be real time, cheaper, scalable, right? And anything they want to integrate, any type of data that comes, they wanted to integrate. And that is how they came to us and asked us, like, can we migrate to some big data solution? And we recommended Hadoop, and then the migration took a lot of time. That is a different case altogether. There is something called MPP. MPP means massive parallel processing. So a lot of people came saying that, so these systems are actually Teradata and all are really faster actually. I mean, not like Rdbms, but they're faster. Okay. So a lot of people came up and said that, okay, if your data warehouse is very slow, why don't you do parallel processing? Okay. You install it on 4 or 5 machines and you can do parallel processing. That is possible, but still the same problem exists. You cannot physically divide your tables. Only logical division is possible. Like I said, country based you can divide, or month based you can divide. End of the day, if you want to do a join operation or something, same questions will happen. So I can never propose this as a real-time solution. So that is my crux of what I'm trying to tell you. And this is how even ICICI Bank was running. And cost was another problem. They had a lot of cost involved. So, and obviously, since they wanted to collect a lot of unstructured data, they wanted to go to a better solution. Okay. And that is how Hadoop came into the picture. And then you have Mapreduce. Now, there is a catch here. Mapreduce is the default programming framework on top of Hadoop. So if anybody want to analyze the data on top of Hadoop, they use something called Mapreduce. Point number 1. Now, Mapreduce came long back, okay? And today there are a lot of ways to analyze the data, not only Mapreduce. Now, as per your syllabus, the curriculum says teach Mapreduce and then some concepts in Mapreduce. And I will be doing that. But one other thing is that if you want to learn Mapreduce, ideally, you should be an expert in Java, because Mapreduce programs are written in Java or any other programming language. So you can write in Python and other things, but natively people write Mapreduce programs in Java. Now, I know that not all of you are familiar with Java and comfortable with Java. So if I talk a lot about Java, it may not make much sense out of you. But then why you are learning Mapreduce is to help you in Spark. So next you will be learning something called Spark, right? 16 hours of Spark content will be there. Spark also uses similar concepts as Mapreduce. So even though you are not able to understand each and every line of code that I'm writing, that's okay. But you need to understand the logic, how it is working. Because Java programs, not everybody will be able to follow and understand and debug. So that is not expected also from you. But if we discuss Mapreduce, I write a Mapreduce program and we run a Mapreduce program, you should be able to understand what is happening inside that, right? Logically, not like syntax wise, line by line wise, right? So once we complete Hadoop architecture, like tomorrow, I will be discussing Mapreduce theory and Mapreduce programs will be running. And then in the next 8-hour syllabus, we will be completing bit of Mapreduce and going to something called Hive, Apache Hive. So Hive is your data warehouse in Hadoop. So that is more of SQL side. So you can understand that point. So now speaking of Hadoop, our architecture is here still. I just changed a little bit. Okay. I'll just write it here. The question is when all this happened, right? So a lot of people, so I handle a lot of trainings in Hadoop and Spark. So a lot of people ask me that, okay, so we are learning a completely new technology called Hadoop. And I will say that you are wrong, because Hadoop came in 2005. So almost 13 years now. So it's almost like very old, but for people it is still very new, for those who do not understand Hadoop. So in 2005, this framework called Hadoop was created, okay, long back, right? And there were 2 guys called Doug Cutting and Mike Cafrella who created this framework. They took the original idea from Google. So Google was already doing a lot of distributed computing, and Google was dealing with a lot of big data, right? So they published a couple of white papers, and this Doug Cutting and Mike Cafrella, they took the idea from Google and then created a framework called Hadoop. And later they gave it to Apache as an open source project. So Hadoop is a open source project actually, which means it is with Apache right now. You can download it for free, install it for free. You don't have to pay any money. But if something is really free, you have drawbacks also, right? Correct? For example, you have Android phones. I have an iPhone. I used to use Android phones, but you know the difference, right? The difference is not show off. That is not the difference. The real difference is that Android phone might get a lot of bugs, which may not come in an Apple phone. If you have used both, you will understand. The problem is Android is open source, right? And open source means every company will modify according to the requirement. As Samsung phone will have their own Android, right? So accordingly, a lot of bugs may come. The platform may not be so stable as it is. If it is an Apple phone, only Apple produces it, right? And if there is a bug also, if I call Apple or somebody call Apple, they will fix it. Because there's only one version of it available. And they know what bugs may come, may not come. So the same story here, originally it was Apache Hadoop. And even still you can go to the Apache website and download Hadoop. But soon people realize that if they are using Apache Hadoop, it is open source. But if something does not work, something crashes, nobody is there to fix it because it is open source. And accordingly, a company called Cloudera Cain. There is a company called Cloudera. You might have probably heard. Cloudera is the first company which created a commercial distribution for Hadoop and related tools. So today you can go to Cloudera and ask them to give you Hadoop. What is the advantage? You will be getting the same Hadoop, almost similar what you find in Apache website. But if you install it and if something is not working, they will fix it. You have a support. Since you are paying money, you get support, just like a vendor, right? So one of the companies which is very popular in the world of big data is Cloudera. So they sell Hadoop, Spark, everything as a bundle, okay? Even your lab actually has Cloudera distribution. The lab we are going to use actually runs a Cloudera distribution. Only thing, they should also provide a free version, and they do it. So if you go to Cloudera, you can download the Cloudera's product for free. You don't have to pay any money, but you will not get support. So what people do, they will buy only with support, right? So if I want to sell Hadoop, I can start a company, I can download from Apache, modify the source code, I can sell it to you guys. But two things, one, I should give a free offer also, no support. Second thing, that is the story with every open source, right? You have Ubuntu Linux, you have Red Hat Linux. What is the difference? Hadoop, and you can download from their product. Cloudera's is not 100% open source, it's a custom product. But you can download it for free from their website and install it on as many machines as you want, but you will not get technical support. So ideally people will not do it, right? Because you need technical support, so you will pay money and get it actually, right? But these are the companies, the Hortonworks and Cloudera as the leading vendors in the big data world. They also provide certification. So if you want to write a certification exam, probably after the Spark class, you can try that. Cloudera provides certification exams in the big data world. You can write it and get. There is also one more company called Mapr. To be very fair with you, why still people are trusting all these companies, Microsoft or Apple or Oracle? They get support, right? Something doesn't work, you cannot be able to fix, right? You have to call them and make them fix. So Mapr is the third company, which is sort of like popular. This company, if my information is correct, was created by a couple of people who quit Cloudera and Hortonworks, Indians only, right? And they found this company called Mapr. Mapr is very popular these days, actually. No? A very, very popular vendor. The highest paid edition is also Mapr. Mapr's architecture is also very different, not like traditional Hadoop architecture, right? So for that reason, like I went to GE, I went to Flipkart, they are all using either Hortonworks or Cloudera. They don't use Mapr much. Apart from this, IBM has their own flavor. It's called Big Insights. Microsoft has their own flavor. That's called HD Insight. HD Insight is there. Amazon has. Every company has an edition of their own Hadoop and big data platform. But most popular ones are Cloudera, Hortonworks, and Mapr. These guys are the most popular ones actually. For a developer, there is not much difference. For example, if you are writing a Mapreduce program, it will run the same way on all three platforms. There is not much of a difference. The difference actually is that Hortonworks is totally open source. They sell the same what Apache gives. Cloudera modifies it a bit, and they say that with the modification, Hadoop is more stable. That is their claim. We don't know. It's all marketing gimmick. It is same like buying an Android, Samsung mobile phone and HTC mobile phone. What is the difference? End of the day, internally it is Android. But Samsung will say that our Android is better, more bug-free or something. HTC will say that this phone will never hang. So only HTC or Samsung know what they have done inside the phone. But end of the day, if I download, let's say WhatsApp, it will run on both the phones, right? Because it is Android. So same thing only. It's just a commercial distribution. Same story with Linux. You can buy from Red Hat. There is also one more provider, right? SUSE. Red Hat Linux, SUSE Linux, internally everything is same. If I type an ls command, it will work both ways. Kernel might be slightly different, but end of the day, they are paying open source original Linux only. So same story here, but considering the platforms, Cloudera seems to be more popular, okay, because they got a head start. 2008 they started, right? Long back they started. Hortonworks is also gaining a lot of popularity these days. I have been seeing that. And why you are learning Mapreduce? Two reasons. One is migration. A lot of companies will already have a lot of Mapreduce programs and they want to go to Spark. So if you want to go, you should know what is Mapreduce. Second reason, even for learning Spark, the concepts of Mapreduce are important. Spark also was built on the basic idea of Mapreduce. So how Mapreduce works, how the program runs, these basic concepts, if you can understand, that will help you to learn Spark in a better way. That is the reason we are learning Spark, Mapreduce actually. In the enterprise, totally gone. There is nothing called Mapreduce. And so always you cannot say that Hadoop is 100% replacement of data warehouse. Okay, it can work as a data warehouse, but performance considerations are there. So sometimes you might need some reports within milliseconds, second, 2 seconds, which probably Hadoop may not be able to do. Hadoop is a batch processing system. It's not real time. So if I have Teradata or what is that, Exadata, Netezza, these guys are really fast. So what companies do, they keep the hot data there. Probably my company has 100 terabyte data. In that, 2 terabyte data I need every day very fast. I'll keep it in Teradata. 98 terabyte, I'll dump it in Hadoop. I need it once in a while, and even if it takes some time, it is fine. Okay. Same story with the cloud. So most of the organizations are now deploying everything over Amazon Web Services. So Amazon offers fully managed Hadoop solutions on the cloud. Like you can go to Amazon, ask it, give me a Hadoop cluster. In 10 minutes, you will have fully functional Hadoop solution. Everything installed, up and running, servers, everything. Automation, right? So there they also give you data warehouses. They have something called, there is a solution called Redshift. Redshift is an online cloud-based data warehouse. So Amazon offers Redshift to you if you want hot data to be stored. So, like I said, everything cannot be given in one solution. You need cheaper, you need the same speed, everything you have to package in one solution. It may not be possible, right? So like someone was suggesting, right? You can compromise speed either, right? Or real-time access, right? So same like that. So Hadoop is a solution most of the people adopt, but not everything can be guaranteed at the same time. That takes us to the question, what is Hadoop and why this is so popular, or what is the architecture of Hadoop? It's fairly easy to understand actually, because the idea is very simple. I have a single machine. How much amount of data can I store in a single machine? Motherboard, right? Motherboard is who decides. So the motherboard will say, I'll support 10 hard disks, you can have 10 hard disks. So the idea is very simple. So people initially thought, I can use one machine. And when that machine was not sufficient, what they did? External storage, NAS and all, right? Network storage. Probably you guys are not much from storage background. There was something called network attached storage. Very, very popular. Have you heard about EMC and all? Company called EMC Square. They survived only because of these things. So you have something called network attached storage, NAS box. You can buy a box, install the box anywhere, and you can dump the data there. So the system can dump and process from there. That is called NAS. So that will support more storage actually, but it is not within the machine. When NAS was not enough, came SAN, Storage Area Network. SANs are even popular these days, okay? So a full room full of hard disk, you get a fiber channel connection. So if I can dump all the hard disk there, I can store as much as I want. But the problem is, even if I'm using a SAN, this gives me unlimited storage, okay? Problem is, it gives me only storage, no processing. If I want to process the data, can one server process all the data in a SAN? No, not possible, right?
This brings us to the end of this video on Big Data Analytics for Beginners. Thank you very much and have a great learning ahead.
I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.